All right, so in this video, we're going to talk about corresponding angles, alternate interior angles, and alternate exterior angles. Now, in the setup, we have two lines that are intersected by the same line. We call this line a transversal, and what you can notice here is that we have a total of 8 angles. The pairs of corresponding angles would be these. So overall, angle 1 and angle 5, angle 2 and angle 6, angle 3 and angle 7, angle 4 and angle 8. Those are what we call corresponding angles. Other pairs of angles include angle 3 and angle 6, angle 4 and angle 5. These pairs are what we call alternate interior angles. And other pairs would be angle 1 and angle 8, angle 2 and angle 7. These pairs are what we call alternate exterior angles. So these are the definitions. And what we're focused on in this video is what happens when these two lines, L and M, are parallel. Well, it turns out that if these two lines are parallel, then all pairs of corresponding angles are congruent, all pairs of alternate interior angles are congruent, and all pairs of alternate exterior angles are congruent. Now, I'm going to redraw this figure such that these two lines are parallel. So we're saying that line L and line M are parallel. And it turns out that if the lines are parallel, then all pairs of angles that we have here are congruent. Now, for the case of corresponding angles, we call this the corresponding angles postulate. For alternate interior angles, we call this the alternate interior angles theorem. For alternate exterior angles, we call this the alternate exterior angles theorem. So what this means is that for the case of corresponding angles, we take this as an assumption. In other words, we accept that if these two lines are parallel, then each of these pairs of angles are congruent, and we accept this to be true without proof. As for alternate interior angles and alternate exterior angles, these can be proven from things that we already know. And so our goal is to prove that this is true. So I'm going to first construct our statements reasons table. And for our first step, we're just going to write down what we're given, which is line L and line M are parallel. For step 2, we can say that the pairs of corresponding angles are congruent, right? Because that's a postulate that's assumed to be true. So we can write down that all 4 pairs of these angles must be congruent. And again, this is the corresponding angles postulate. Now for step 3, we can apply the vertical angles theorem, which says that all vertical angles are congruent. Now notice we have 4 pairs of vertical angles. That is this pair, this pair, this pair, and this pair. So all 4 of those pairs of angles are congruent. And again, this comes from the vertical angles theorem. And at this point, all we have to do now is apply the transitive property from step 2 and step 3. Notice that both angle 3 and angle 6 are both congruent to the same angle. Therefore, they must be congruent to each other. Also, both angle 4 and angle 5 are congruent to the same angle. Therefore, they must be congruent to each other as well. But really, these are our pairs of alternate interior angles. And we can also use the transitive property to get our alternate exterior angles as well. Notice that both angle 1 and angle 8 are both congruent to the same angle. Therefore, they must be congruent to each other. Also, both angle 2 and angle 7 are congruent to the same angle, so they must be congruent to each other. And these would be our pairs of alternate exterior angles. And so this is what we've done, and we've done this by the transitive property. More specifically, the transitive property of congruence. And so as you can see, we have reached the conclusions that we wanted to reach. We wanted to prove that the pairs of alternate interior angles are congruent and the pairs of alternate exterior angles are congruent, and that's exactly what we did. And so this proves that they are in fact congruent. And so yeah, that's pretty much the whole idea of it.